Welcome to ClickMyProject.com. Our project title is Cognitive Workload Classification Using Machine Learning Algorithms. This is our abstract. In particular, development of the operator mental state monitoring utilizing electroencephalogram inputs is made possible by machine learning. Its subsection deep learning approaches. Although several machine learning techniques have recently been presented for identifying cognitive stresses using EEG. There does not yet exist a review that covers in depth all the application of ML methods to alleviate this gap. In this paper, we survey cognitive workload and the machine learning literature to identify the approaches and highlight the primary advances. This project is based on finding the workload classification as normal, medium, high level stress level by the prediction of temperature, humidity and step count, and also calculate the comparison for the 3 ML algorithms. This is an abstract. Developer stress classifier. It classifies stress into high, medium and low. It improves the accuracy of classification, improve the prediction of stress level. This is a system architecture. From the data selection, this is the first module. Here we use the CSV file for the data. First module is the data selection and then data pre-processing. In this data pre-processing, we do the label encoding and then standard scalar and then handling the missing values. And then data splitting is nothing but to split the data into training and testing as the ratio of 80-20 ratios. And the classification, in this classification we fit the ML models like SVM, RF and DT. SVM is support vector machine, random forest and decision tree. And then finally we predict how the classes classify our stress status. And then performance analysis. Here we calculate the accuracy, F1 score and then sensitivity, scarcity. And this is a flow diagram from the data selection and then move on to the data pre-processing by the missing values and the label encoding, and then data is splitting 80-20 ratio of training and testing data, and then classification SVM, DT and RF, and then in the prediction and the performance analysis, accuracy and the loss and the sensitivity and the scarcity. And then this is a use case diagram from the user point of view, what the system will done. This is a use case diagram. Data selection and then data pre-processing, data splitting, classification, prediction, performance analysis. These are done by the user and these are done at the system. We write the code and then step by step its process is done. And then this is the ER diagram from the starting point, from the start, and then load data and then data selection, data pre-processing, data splitting and then performance analysis and then prediction and then classification. This is a sequence diagram from the start point, select data, unload data set, data selection and then data pre-processing. Here we choose the which model selection and then classification and then finally data splitting. After the data splitting, move on to the performance analysis and then the prediction. After executing our process in console, it executes our program. First step is the import library, next is the data reading, and then second step is the pre-processing. Here we select 0 to 100 rows only. That 100 rows will be split up to sections. We drop out 3 columns into 2 into 1 and this is a standard scalar, one of the pre-processing method. Here we convert the values of we convert the arrays into the whole set of numbers, and then data splitting. Here is the test train x and test train y and testing. These two are testing and these two are training, and this is the pair plot for our data set. This is a we in our data set we have the three level of stresses: 0, 1, 2. 0 means it's mentioned about the normal, and 1 means medium, and 2 means high. And this is a count plot. These are those 0, 1 and 2, and this is a strip plot. And then this we apply the three algorithms. First one is the TT classification. Here is our model is predicted correctly, so 0, 1, 2 is correctly. And here confusion matrix, this is a classification report, and this is a confusion matrix chart. And then this is a SVM classification. Here our SVM classification accuracy is 98.5, and then the precision recall F1 score for the three classes, and then confusion matrix. And then this is in the confusion matrix in the form of a chart, and this is a RF classification. Here also we use the accuracy classification report and the confusion matrix, and then finally our confusion matrix like this.